Alrighty, folks, we are ready to roll. We're going to learn us some linear inequalities. We're going to be solving, we're going to be graphing, we're going to be doing all kinds of fun things. We're also going to maybe not write so fat because that's really hard to see. All right, so this is so review. You already know all these things. Back in the day, you learned less than or equal to, greater than or equal to, where the alligator mouth is always looking for the biggest meal. And so this wide open part is facing the largest value. So some things to think about. These guys who do not have the line under them are not inclusive, and that means they don't actually include the value where your arrow will start. So you indicate that with an open circle, meaning you can go right up to that value but not actually use it. These bad boys have an inclusive line under them. It's less than or equal to, greater than or equal to, and so you'll indicate those with filled in circles. This is not earth-shaking information. You already knew this. Now, when you look at my arrow direction, less than, numbers that are less than on the number line tend to be to the left. And then here, when you have greater thans, those numbers are going to be to the right. And so you want to kind of look at that and think about which direction am I going to draw my arrow. All right, so let's do a couple of these fun things for realsies on these examples. So here I'm looking to graph x is greater than or equal to -1. I'm going to throw me down a -1 right here, and I'm going to mark that as -1, and it's or equal to, so I make sure that I have a nice filled in circle so my teacher can see that I know what I'm doing. And then x is greater than, numbers greater than, that would be to the right, so I indicate with that. All right, so those are the details you want to pay attention to. Which direction does your arrow go? Did you label your starting number, and is it properly marked with an open or closed circle where I don't have to question whether it's open or closed? Here I have a 1/3. So if this is my 0, I'm going to make a third really close to that. This one's not included, so I'm going to put it as an open circle, and I'm going to mark it because obviously I can't tell that's a third versus a half versus a fourth. And so you mark it, and then less than is going to go off to the left. So this is easy peasy math. So we are good at that. Let's take it up just one little notch because we are honors, and it's way more fun to have a little bit of a challenge here and there. These are compound inequalities, and compound inequalities simply mean exactly that. They are made of more than one thing, like a compound in chemistry or a compound sentence. So they come in sort of two forms. Here where x is in the middle, I always think of these as betweens, but these are and statements. Your x has to be between two values. That's pretty poorly written, but you get the idea. So for example, it has to be less than 2, but it also has to be greater than -1. So it's in between them. So from -1, 0, 1, 2, it's going to fall in between. So it's not equal to either of those because neither of these is inclusive. So I have open circles at both spots. Less than 2 but greater than -1 would mean my overlap of those two regions is right here. So again, you're kind of looking for an overlap. It has to be both things, not just one or the other. In fact, if it's going to be one or the other, we call that an or statement, which is really convenient. And I always think of it as oars on a boat, because if you're in a little boat and you need to use your oars, they're going to be going out each direction, and that's typically what your graph is going to look like versus kind of the line segment that you saw with the between statement. So in this case, my x has to be less than or equal to -2, which is obviously right here, or equal to gives me a big fat blob, and then less than is going to go this direction. Or it's also acceptable for it to be greater than 1, so that'd be 0, -1, 0, 1. Here we go. And it would be greater than that, not or equal to, so that one's open and the arrow's off to the right. So that's typical. But as you know, things are not always typical. So in this case, this looks like an and I'm thinking, oh, it's going to fall in between those numbers. But this is two statements. First of all, -5 on the number line is here, let's say, and then that's going to be -4, 3, 2, -1 would be right here. This part tells me that x is less than that, so that would actually be going off to the left from here. And this part, because the alligator mouth is open towards the x, says that x is the bigger part, so the x's would be greater than that. So the problem here is that there is no overlap. There is no place where that is both things, because with and we have to be both things. You have to have brown hair and blue eyes, not one or the other. It's got to be both. So in this case, with no overlap, there's no answer. And because there's no solution, then we have to say there's no solution, or it's, null set. So that's kind of like a weird scenario that can come up. And so my graph is actually going to have nothing on it because there's no place that falls into the criteria that was given. And so my answer for a test or quiz or homework would be that there's no solution to this. They don't overlap. Here I've got or, so I'm expecting 2 little ors off in each direction. But again, I pay attention to the number line. If this is -2 and it's or equal to, but then it's greater than, x is greater than would actually go off to this direction. Here, for x is less than 1, keep in mind that if that's -2, I've got -1, 0, 1 right here. And I need to be less than that. So I'd have an open circle and an arrow to the left. So this arrow goes forever to the left. This one goes forever to the right. And this one just like runs right on through the part that was an open circle. So it's no longer open. So what ends up happening here is the entire number line is filled in to make this statement true. And so then we would say that this is all reals. Or you can make that big fancy R to indicate that. So those are 2 kind of weird little exceptions that you might run across. Okay, just graphing is way too easy for us. And so what we're going to do instead is we're going to work a little bit on this solving part. And we're going to talk about that. So let's talk about kind of some things to think about when you go to solve these. First of all, you're just going to find x like normal. So you're just going to solve per usual. So nothing fancy. And if you're like, I don't know how to solve for x, then you're totally in the wrong class. And then one thing to think about that makes it easier, you don't have to do it, but with inequalities, it's tricky to read them backwards. I suppose most things are tricky to read backwards. So anyway, what I try to do here is I try to get the x or whatever variable it is on the left of, your less than, your greater than, because otherwise it's too hard to read and you have to think backwards and that can be dicey. Here's the clincher, and you've learned this before, but you have to put it back into the front part of your brain instead of the back part where it's been staying for most of the years. In these problems, if you have to, in your process, multiply or divide by a negative, then you have to flip the symbol. And that is something that nobody's going to remind you of. They're not going to tap you on the shoulder and be like, hey, dude, you got to flip the symbol on this one. You just have to remember that, because if you think about the number line has positives over here, negatives over here, and the positives are greater. So those, a greater than symbol would be facing, your alligator mouth would face to the right. But if you came along and you multiplied all the numbers on the number line or divided them all by a negative, negatives times negatives become positive, and positives times negatives become negative. So now you've switched the values and your alligator is going to turn around and go the other direction. So that's kind of the math reasoning behind why you have to do it, but the harder part is just remembering to do it. So let's use our festive pink to go ahead and solve this first one. I like to look at all the verbs on a test or quiz because if I only do part of what it says, I would only get part credit. So I'm going to need to solve and also graph. So if this was an equal sign, my first reaction would be to move this over by adding this -5. But I remember that I learned up here, I want to get x on the left to make my life easier. I'm all about making my life easier. So I'm going to go ahead and subtract the 7x. Then it's gone over here. And over here, I'll have -12x. I still have my +2 greater than or equal to -4. So now I'm going to subtract the 2 over to the other side. So at this point, I'll have -12x is greater than or equal to -6, and I'm going to go ahead and divide by -12. 2 things are going to happen. 1, lots of people are going to think, oh, the answer is 2, but the answer is not 2 because I'm dividing by that -12. And I'm struggling here. That's a big blobby mess. So this becomes 1x. This actually becomes a positive 1/2 because that's going to reduce to a 1/2 and the negatives cancel. And more importantly, I divided by -12, so my little symbol is going to turn around and go the other direction. So my final answer is that x is going to be greater than or equal to a 1/2. So if this is 0, then a 1/2 is right here. I'm going to mark it. I'm going to fill it in, and then I'm going to do less than. So I'm going to head off to the left. where if I had looked at the original problem, I would have guessed that it was going to go off to the right. So you just have to kind of be smarter than the paper and think about those scenarios when they pop up. This one looks kind of fun because this is an and problem. It's in between, but you really don't do anything differently. If you were solving this part on any other day, you would add 10. So you go ahead and you add 10. You just have to add 10 to all three parts rather than just the left and right side. So that cancels. Here I have positive 6. In the middle I have my negative 6x, and to the right I have a 24. Now I look at the middle, the part I'm trying to solve. I'll need to divide each piece by a negative 6, and the little red flag is going to go up and say, hey, I have to remember to flip the symbols. So this is going to turn into a negative 1. This flips. That one's going to cancel, leaving me with just x. This also flips. I have to flip both symbols. I actually didn't keep that little or equals to, so I have to keep track of that from the beginning. Attention to detail here in honors math. And then this will become a negative 4. But because we're in honors math, we still have some more tricky business to do. If you're going to put these on the number line, negative 4 is actually going to be to the left of negative 3, negative 2, negative 1. So you have to write this so that it's in the proper math order. Negative 4 on the left, negative 1 on the right, x in the middle. But you have to keep in mind what was the case here. So for example, here, the alligator mouth is open towards the x because the x is actually greater than the negative 4. So it would look like this. If you looked at this portion of our compound statement, the alligator's facing the negative 1 because that is the bigger value. And so this is how you write your solution. And then when you come up here, you're going to say, okay, this part's or equal to, this part's not, and my x is in between those. So there's a lot of little things to keep track of. Even though you've studied this concept in the past, we want to keep track of that. All right. This one's going to be an or statement, and with an or statement, I already know I'm expecting kind of two arrows facing away from one another. This, unfortunately, is a sneaky way to make you do two problems at once because you're going to just have to solve them separately and then graph the two parts. There's not a way to do them together like the last problem. So I'm going to go ahead and distribute my 5 and get 5x minus 10. By the way, with all of these, it's like super boring to watch me do math, I'm sure. So the smart thing to do is when you come across some of these examples, turn off the video and then solve them yourself, and then come back to the video and see if you did them right, you know, and maybe skip ahead and see if you did it correctly. Then you obviously don't have to watch me go through it. So then if I add my 10 to both sides, I'm going to be looking at, if I add a 10 over here, a negative 2. And then when I divide both sides by 5, I'm going to be looking at x is less than negative 2/5. And even though there's a negative in the problem, I didn't divide by that. So that's going to be the first half of my answer. Now, if I take a look at the second half of my answer, I'm trying to solve this problem. I'm going to just take away the 5 from both sides. So now I'll have 1/3 x greater than or equal to 4 when I do the 9 minus 5. To get rid of the 1/3, I'm going to multiply by 3. Keeping the world fair, I'll multiply by 3 over there. X is greater than or equal to 12. So the math is easy peasy. Now, when it comes time to do my verbs, I need to solve. So I would write x is less than negative 2/5 or x is greater than or equal to 12. And you have to have the or because you're making a compound statement, and it is not an and, it is an or. When it comes time to graph, I'm going to be at positive 12, which is way the heck up here somewhere. So I'll label that, and then I'll go off to the right because it's greater than. And then for negative 2/5, I don't know where that is, but I'm just going to throw it down way here to someplace. I'm going to label it so it looks like I know what I'm doing. I'm going to keep it open because it's not or equals to. And then I'm going to draw an arrow to the left. This is so fun. All right, so this is a pretend question. Because it's about the state fair, which is no longer a thing, apparently, at least not this year. So with word problems, keep in mind that they always have to do with what you're learning. And what we're learning right now is inequalities. So it's telling me ultimately what I have to do. I'm going to write, solve, and graph. Those are my verbs, write, solve, and graph. And if I don't do all of them, I won't get all the credit on a test or quiz. I'm going to have $70 to spend. I'm going to spend 14 to walk in the door, and I'm going to buy me some cookies for 16. I also want to play a game that costs $2.75. All right. I'm going to write, solve, and graph inequalities. It's got to be one of those to model the possible number of times n. So don't use x or you're going to lose a little bit of credit to play the game. Attention to detail. Okay, so I need an inequality. Well, start thinking about the money you spent. $14 to walk in the door, $16 for a bucket of cookies, $2.75, but that's per game. So per is going to mean I'm going to multiply it by however many times I play the game, and they told me to use an n. Excuse me. I have $70, so that means I have to do all of those things for less than or equal to $70. That's the hardest part, is putting those words into a problem. Now I know how to solve. That's 30. So if I take away 30 here and here, I'll be at 275. And I know you can do this problem in your head, like just take away the money that you spent and divide by how many, games. But we're showing that we know how to write and solve these, because getting them into a math statement is the hardest thing. So dividing this out, if you bust out your calculator, if you can find it after 6 months, I actually get this. That's not going to be a full credit answer on a test or quiz, however, because you can't play half of a game. So the correct solution is going to be written like this, but also have this end. Because in the real world, as they say, you can't play this game a negative number of times. So the proper solution is going to go from 14 included on down. Let's go 12, 10, 8, 6, 4, 3, 2. Let's just put a 0 here and say you can play anywhere between 0 times and 14 times. All right, so there you have it. Now you're super smart. You know everything you need to do to tackle the lesson number 2 worksheet. You can do it on Notability. You can do it on paper, out of your packet, whichever floats your boat. And then make sure that you are prepared to ask your questions on whatever your next in-class day is. All right, peace out, guys.